Welcome to the second part of the Entity Framework tutorial. Entity Framework tutorial a little bit extended than the normal ones. What we're going to do today is we take a look at some sophisticated configuration examples and how we can dive a little bit deeper into stuff like user-defined logging, tracing, and user-defined configurations. Okay, to start with, I just want to show you what we have. We have here our data core is our data access layer. We have unit tests here, which we will use to call our things we will do, and we have some interfaces here. This is not important today. It was very important in the first part of this series. So what I'm trying to start with is just to introduce you with configuration of Entity Framework. If you haven't heard about the class DB configuration, this means you never dived into the user-defined configuration. The purpose of this class is that Entity Framework says, hey, if you have some type in all the assemblies I see when I start, which is derived from DB configuration, I will assume that this is your user-defined configuration class. So my Azure configuration class is my configuration, and I am allowed to have 0 or 1 of those configurations. Because Entity Framework, if I have, let's say, 2 or 3 DB configuration classes, Entity Framework wouldn't know which to take. So what I normally do in these configuration classes, the pattern is that I use the constructor to call some methods, and as you can see, I just commented out 3 of them. We will take a look at them later on. And now I'm only using the SetExecutionStrategy method. This method is interesting because it can be used to tell Entity Framework to use different type of execution strategy type depending on what you are targeting. Let's say you are targeting Azure, which is very special in terms of databases might be there and might be gone in the next moment, and then they are back again. And for all kinds of scenarios like this, Microsoft provides in Entity Framework a SQL Azure execution strategy, and we will use this strategy depending on a switch, which is this one, support suspend execution strategy. If this is false, we will use Azure. So where comes this property from? It comes here. I defined it myself as a static bool, and this bool just uses a thing called call context, which is provided by DB configuration. And call context has a method logical get data, which means hey, give me from the current context where I'm in, give me the data under this key, and if you get it, okay, let's deliver the value, or otherwise assume that it's false. So the default would be that it uses a SQL Azure execution strategy in my scenario. So this value is has to be set in our context, and if I switch to DB context util, you will see that in the constructor of this DB context util, I say globally, hey, let's switch this to false so that Azure will be used certainly all the time. If I don't want to use it for any of my commands later on, I just can temporarily switch it back to true. Then it will be then this configuration will say, hey, use please the default execution strategy, and I can switch it back to false to take again Azure SQL Azure strategy. So this is very nice. I just can execute this one. I just close those. We go to our unit test, which this is a simple query test, and it just takes a count on one of my entity sets, and I just run this test. And let's take a look in the Test Explorer. And no, this is not a proof, but it shows, okay, it's principally it's working. So you can try it out for your own projects. I go back to the configuration and just set the strategy as you need it. Okay. The second thing which I want to show you is how can we just create more sophisticated logging. I just switch back, go to my unit test, and I show you what the point is at this moment. I just hit a breakpoint here, so it's better to debug. I just debug the test, and now we take a look at the output window, and you will see here that we have some informations that came out from Entity Framework. For instance, our select statement here. You see it? Select statement is formatted with tabs, and this might be nice if I'm debugging those stuff, but it's pretty annoying that it's taking all this white spaces and empty lines and stuff like that. It's just destroying my output window very confusingly, and you can take care of this. So first of all, just to repeat, where does this tracing come from? It's coming from the DB context util, because we are saying that the default logging, this is the line which is it, should be sent to this action, trace information m. M is the message, the string, which has to be traced. So this will be, this stays here in this class, but we can tell Azure in the Azure configuration, in Entity Framework, excuse me, inside our user-defined configuration, please take for log formatting, this is a method, set database log formatter, just please take this class, the one-line formatter, which I'm implemented here by myself, just show you. This is the class, it's inheriting from database log formatter, and it's just to show you, it has a default constructor, okay, and here are some methods which I can override. There are more overrides on database log formatter, but I'm just using those. Okay, I say when a command has to be logged, please do it this way. A result, please do it this way, and then when the connection is opened and the connection is closed, do it this way. And what I'm doing here is, oh, it's gone already. For the command text, I just simply replace environment new line by an empty string. It's not the best way to do it, I know, but it shows what I mean. And another interesting thing is that when the result comes back from the database and he wants to show us this, I'm using something which comes out of this interception context, and I can tell you if the method which was executed on the DB, if it was async or sync. And I just told or tell you this information too. So I have this class. I configured this class to be used by Entity Framework as the default log formatter. And now I just go back and debug again. And this will bring a nice, clear, formatted stuff without empty lines. And you see here the command is in one line. And we see it was a sync operation because it's count, not count async. So this is cool. This is very, very useful for me, and I think for you too. So you can, which most people don't know, you can take care of how your log action, which you define here you define your log action itself. And when you want to take care how M, the string here, the message is formatted, you can do it this way with your own one-line formatter or whatever you call it. Another much deeper way to go into Entity Framework is provided by Interceptors. If we just first of all take a look in the object browser and just search for interceptor, you will see that there are a lot of interceptors in system data entity. All interfaces, I, DB, interceptor, are possible interceptors for you. What I did is I just used a nlog command interceptor and explain you later on, and it's implementing IDB command interceptor. IDB command interceptor, if we take a look at the interface, provides these methods. So it's always the same pattern in interceptors. It's before something finished and after something finished, like event patterns in UI frameworks. So you have for non-query executions, for reader executions, and for Scala executions, you have certain methods which you can implement. And so my nlog db interceptor just says, oh, they are just, I'm not interested in this one, I'm just interested in reader executions. So after a reader was executed, I want this tool to debug a line into nlog, which I use. Nlog, for those people who don't know what nlog is, it's a logging framework which you can use by implementing a NuGet package, and you have to just to set up nlog a little bit, and then it logs to a file, to, I don't know, to database, to Windows application log, how you want it. So I'm just using this, and what you can see here too, I'm again replacing something because I want one-line logging. And you could ask, why are you doing that kind of stuff? Because you already have this one-line formatter. The point here is that the one-line formatter here only is used for the normal tracing, for the normal logging of database. If I'm using interception, I'm going much deeper into entity framework, and I'm hooking into a place which is much more deeper in the core than the normal log action. That's why it's not taking the one-line formatter when I use an interceptor. So again, when I just run this one in the unit test again, let's say I just run it, I don't have to debug it, and in parallel I will open, excuse me, just have to do this, my folder where logging happens. Yeah, there it is, Notepad++. You can see here my nlog action, just to prove that this one is used and it's not a fake. Run test, and let's see if nlog gets, is it ready already, or is it I want to prove it and now it doesn't happen. Yeah, now it's coming. Yes, and here are the messages. This is because there's a some time period, because nlog is writing in flushes. So as you can see, you using using this kind of interception logic, you are able to hook in deeply into entity framework itself and react on stuff happening there. There are a lot of other interfaces, interceptor interfaces, like the command tree interceptor, which you can use to hook into building up the commands itself. The configuration interceptor, which is providing you a method to hook into the moment when the configuration is loaded, even the configuration you overloaded, but when it's loaded visible for entity framework, you can hook into that. And then there's a huge interface, IDB connection interceptor, which takes care of things like I got the database, I got the data source, I got the connection string, I'm closing the connection, I'm opening the connection, things like that. You have begin transaction on the connection, but you have the transaction interface itself too. IDB transaction interceptor, which is more detailed in terms of dealing with transactions. And you have the IDB interceptor, which is a flag interface, as you can see here. It's just showing you, here I want to intercept when DB comes. So, this is interesting, I think, too. So, Azure configuration. And this one is used, the add default resolver thing is used to implement custom dependency resolvers. I'm struggling with this at the moment. I just have to deep a little bit more into it, but I can show you how it works. I just implemented something by implementing the interface IDB dependency resolver on some custom class. And this has two methods, get services, which calls this one, get service, and I just included tracing here. So I just want to show in the trace that this interface comes into place. What my plan was to say, when Entity Framework requests IDB command interceptor, please give him my nlog interceptor. Now I want to do this because it's a much cleaner way to implement the interceptor than to do it in a raw line of code like this. I don't like this because it's not dependency injected, it's hard coded. So if I want to replace the nlog command interceptor with something else, I would have trouble. I have to rebuild and redeploy my solution. That's not good. So instead of this, I want to use this, the default resolver, which is this dependency resolver, and now I want to test it. And it won't work. But I show you what comes out. Just debug this because we want to see the traces. You see he's writing a lot of stuff. Let him finish. And now we go back to the top, and here you can see, if I just show you, we just wrote get service and then the name of the type which was requested. And you see here's get service func. It's not interesting, but here DB provider factory, he wants an iDatabase initializer, a provider factory resolver, blah blah blah, provider invariant named. He shows us all the stuff when Entity Framework wants something. Entity Framework just don't says, hey, I have this provider invariant name, I want something for providing me an invariant name. And the dependency resolving infrastructure, which is built into Entity Framework, will give him this service. So, and now the point is that at no point in time, sadly for me, something requests an IDB command interceptor. And this is because I misunderstood something I have to deep into, but if you have an idea how I could bring this this breakpoint to into work, please let me know. Please leave a comment. I'm very interested in that. If I get the answer by myself, I will come up with a comment too. So that's all for this thing, for configuration. I want to show you in later tasks or screencasts of the series, I'm planning to show you some real-world scenarios and some things which are not working that good as you probably expected, and how to circumvent these scenarios. I'm planning on this, and I'll come back with a new screencast when I'm ready. Thanks for listening, and bye.